Matrix, welcome to Was a Matrix. My name is Looney and today we'll be doing your exam prep for maths. I'll be assisting you to get all of your questions and comments through to us, so all you need to do is follow Was a Matrix on all of our social media platforms, check us out on our WhatsApp line, and if you miss any of our videos, they are available on YouTube. All of the details are on the screen. As always guys, we've got a cool competition going on for you, so do stay tuned to get all of those details. I'm not alone. I've got my favorite sign language interpreter with me, Nicolene, as well as our awesome teacher, Nicola. Thank you so much guys, and over to you.
Thank you so much, Looney. I really appreciate the introduction. And welcome everyone, welcome Matrix to your revision preparation for Mathematics Paper 1. We're going to go through quite a lot of material today. We're going to try our best. We're going to be doing a little bit of algebra, some sequences and series. We're going to be doing some functions, a little bit of calculus, and hopefully some probability at the end. So it's a lot to get through, so let's get started with the first question. Okay, so question 1. Show that the roots of x plus m times x plus n equals 3p squared are real for all values of m, n, and p. Okay, so this is a question that's asking us to look carefully at the roots and to understand the roots of this equation. Usually we understand the roots by looking at the discriminant. So really this is asking us to calculate the discriminant and then to critically look at the discriminant and see whether it is greater than or equal to 0 or whether it is less than 0. Okay, so we know that for the roots to be real, the discriminant needs to be greater than or equal to 0. So we need to calculate the value of that discriminant. In order to get the discriminant, we know that that is equal to b squared minus 4ac. So we need to be able to extract the b, the a, and the c from this expression. To do that, we need to get this into standard form. And we can see that at the moment, it is definitely not in standard form. We're going to have to multiply everything out on the left-hand side of the equation, and we are going to have to bring the 3p squared over to the left-hand side to get it into standard form. Don't forget that the variable in this is x, and m, n, and p are effectively constants. Okay, so let's start multiplying this out. We're going to FOIL, so we've got x squared, we've got plus nx, then our inner terms, we've got plus mx, and the last terms, we've got plus mn. And as I said, we're going to have to bring that 3p squared over to the other side, so it's going to become minus 3p squared, and that is all equal to 0. We've got two x terms here. We've got nx, and mx. So let's factorize the x out so that we can get the coefficient of x. So we're going to factorize the x out, and that leaves us with n plus m. Now, these two terms are effectively the constant in this expression. So we're going to keep those at the end, and that is the constant, which, as we know, is equivalent to c. Now that this expression or this equation is in standard form, we can extract the values of a, b, and c. So I'm just going to do it over here. We've got a is equal to 1. b, which is the coefficient of x, is equal to n plus m, and c is equal to mn minus 3p squared. Okay, so now to calculate the discriminant, I'm going to do b squared minus 4ac. It's very important to remember that this is asking us to show that the discriminant is greater than or equal to 0. We can't assume that it's greater than 0 to prove that it's greater than 0. So let's take this expression, calculate its value, and see if we can show that it's greater than 0. So we're going to sub in the values first. We've got n plus m squared, and we've got minus 4 times 1 times c, which is mn minus 3p squared. Okay, that is equal to n squared plus 2nm plus m squared, and then that's minus 4mn plus 12p squared. Okay, I'm going to go to the next page. Okay, so we had sorry, I have to go back. Okay, so we had n squared plus 2nm plus m squared minus 4mn plus 12p squared. Okay, so the easiest way to show that this is greater than or equal to 0 is to actually show that it's a perfect square. So we have two like terms over there, and we can simplify that to now be n squared minus 2nm, or mn, plus m squared, and then plus 12p squared. Okay, we can now factorize this into a perfect square. So we have n minus m all squared, and then we have plus 12p squared. So we can see that this final expression is made up of two perfect squares, and both of those perfect squares are always, by definition, greater than or equal to 0. So n minus m squared is greater than or equal to 0, and 12p squared is also greater than or equal to 0. So therefore, the sum of those two is also greater than or equal to 0. So we can say, therefore, the roots are real because the discriminant is greater than or equal to 0. Okay, let's go on to the next page. All right, so this is a question. This is a question about sequences and series, and let's read it together. 1.2. Given the series 1 plus 2 plus 3 plus and so on, all the way up to plus 5,000, write down the series in sigma notation if all the powers of 4 are removed from the series. Okay, so we're going to have to do this in two parts. We're going to have to find the sum of the first 1,000 natural terms, and then from that, we're going to have to subtract all the powers of 4. Okay, so let's first write just the 1 plus 2 plus 3 plus and so on, plus all the way to 5,000 in sigma notation. So that's going to be the sum as n equals 1 all the way up to 5,000 of n. So we can see that this is the sum of n going from 1 to 5,000 of n. From that, we're going to have to remove all the powers of 4. So if we think about the powers of 4, we need to be careful here. It's tempting to say that the first power of 4 is 4 to the 1, which is 4. But if we look carefully and think very carefully about it, we can see that the first power of 4 is actually 4 to the 0, which is equal to 1. So we now also need to think about what the biggest power of 4 that is less than 5,000 is. So we're going to have to go to our calculator for that. So let's try, if we do 4 to the power of 5, that gives us 1,024, which is less than 5,000. If we do 4 to the power of 6, which is going to be the 1,024 times 4, that takes us to 4,096. So in other words, 4 to the power of 6 is going to be the biggest power of 4 that is inside that series of numbers. Okay, so we can start getting an idea of how we can write the 1 plus the 4 to the power of 1 plus the 4 to the power of 2 plus, and that's going to go all the way to 4 to the power of 6. We can write that as the sum as n goes, or let's use a different variable here, as k goes from 1 up to, let's do 7, and that's going to be 4 to the power of k minus 1. Okay, so I wanted to use a natural number there, so I started at 1, I went up to 7, and we can see that each time we substitute that into the k, we're going to get 4 to the power of 0, then 4 to the power of 1, and so on. And the final answer, we're just going to subtract this sum from that sum. So I'm just going to put a big minus sign in between those. You can write it nice and neatly. So it's the sum of all the first 5,000 natural numbers minus all those powers of 4. Okay, so let's move on to question 1.3. So question 1.3 is about two converging geometric series. So we're given two of them, and as you can see, they're not numerical series, they're actually both in terms of x. So given that the following two geometric series are convergent, and there they are, the first one is 1 plus x squared and so on, all the way up to the end of time, all the way up to infinity and beyond. And the next one is 1 minus x plus x squared minus x cubed, also to infinity and beyond. Okay, so we're asked to determine the values of x for which the sum of those two series is equal to 8. Okay, so they're both infinite series, infinite geometric series. So we can calculate the sum of each of those series separately. To do that, we're going to have to use our formula, which luckily you have on your formula sheet. So the sum to infinity of any geometric series is equal to a over 1 minus r, where a is the first term of the series and r is the ratio, the constant ratio from one term to the next. So if we look carefully at our first series, we can see that very obviously a is equal to 1. To get our ratio, we could probably just get it by looking at this one, but just to be sure, let's take term 2 and divide it by term 1. So we can do term 2 divided by term 1. And we can see that that is equal to, there's term 2 and there's term 1. So we have x over 1, which is equal to x. So therefore, our ratio is equal to x. So we can already substitute into there. So a is equal to 1, and that is 1 over 1 minus. And for the ratio, we're going to sub the x into there. And that is the sum to infinity of our first geometric series. We're now going to do the same thing with the second geometric series. So again, sum to infinity of this series. So sum to infinity, we're going to use the same formula, which is a over 1 minus r. Okay, so for this series, a is equal to 1 again. Now we have to be a little bit careful. This is a series that goes positive, then negative, then positive, then negative. So it's going up and down before converging to a certain value. So our ratio is actually going to be negative here. So we're going to do term 2 over term 1, and that is negative x. This is the second term for this one over here. Let's do a different color. So this is term 2. The 1 is term 1. So we've got minus x over 1, which is negative x. Okay, so we know that our ratio, our common ratio for this is equal to negative x. So let's go to a new page to substitute that in. So we have the sum to infinity is equal to a over 1 minus r. And as we said, a is equal to 1, and for this one, r was equal to negative x. So therefore, the sum to infinity is going to be equal to 1 over 1 minus x, which is 1 over 1 plus x. Okay, so the last part of the sum is to now find the values of x for which those two series, or the two sums to infinity, equal 8. So that's what we're going to do next. So we're going to take the two sums to infinity and we're going to make them equal to x. So we have the first sum to infinity was 1 over 1 minus x, and the second is 1 over 1 plus x. And we're going to make that equal to 8. And now we're going to solve for x. So effectively, this becomes an equation with variables in the denominator. So as per usual, we're going to figure out what our lowest common denominator is. And in this case, it is actually going to be the product of the two denominators. So the first denominator is 1 plus x, or sorry, 1 minus x. The order doesn't really matter though, so that's cool. So we have 1 plus x and we have 1 minus x. So therefore, we're going to put everything over the same, oops, sorry about that. We're going to put everything over the same denominator. So we have 1 minus x, 1 plus x. And we're now going to multiply this numerator by 1 plus x, and we're going to multiply this numerator by 1 minus x. So we've got 1 times 1 plus x is just 1 plus x. And then we've got this plus, there it is, and then we got 1 minus x, and that is equal to 8. Okay, so the x's have cancelled each other out, as we can see. Plus x minus x gives us no x's, so those have disappeared. So all we left with in the numerator is the 1 plus the 1, which gives us the 2. And of course, we have the 1 minus x, 1 plus x in the denominator. And we can actually simplify that to 1 minus x squared if we multiply those out. And that is now equal to 8. Okay, we want to get rid of that denominator by multiplying both sides of the equation by the 1 minus x squared. So when we do it on the left side, well, we just left with a 2, and when we do it on the right side, we're going to multiply the 8 by the whole of 1 minus x squared. Okay, so to finish off, we're going to solve this quadratic equation. It's now become a quadratic equation. And we're going to release the x squared term from the bracket so we can move all our constants around and then solve for x. Okay, so we're going to multiply out. We get 8 minus 8x squared on that right-hand side. We can bring the minus 8x squared over to this side, and then that's going to become positive. And we can take the 2 over to the other side, and it's going to become negative. So on the right-hand side, we have 8 minus 2, which is 6. Okay, we can now divide both sides by 8. Therefore, we have x squared is equal to 6 over 8, which we can simplify to 3 over 4. And the very last step is that we need to now square root both sides. And don't forget, it's really important that when you take the square root of any number, you have both a positive and a negative root. And that's where you're getting your two solutions for the quadratic equation. So we're going to get plus minus the square root of 3 over 4. And we can actually take the square root of the 4. Obviously, the square root of 4 is 2. So we can just neaten that up a little, simplify that surd into plus minus the square root of 3 at the top, and then, of course, your 2 at the bottom. And that is the final answer. So it's for those two values of x that the sum of those converging infinite series is equal to 8. Okay, so that's the end of this segment. So I'll hand back over to Luni.
Thank you, Nicola. Guys, we are going to take a quick break, but don't go anywhere. We'll see you straight after this. Welcome back from the break, Matrix. If you've just joined us, we are assisting you with your exam prep to help with the upcoming exam. If you're someone who's constantly running out of data, then this next competition is just for you. Wazomatrix is bringing you the hashtag WazoWinner competition, where 2 lucky matriculants stand a chance to win 2 gigs of data. All you need to do to enter is head on over to our Facebook page, and all of the details will be there. Thank you so much, Nicola, and over to you.
Thanks, Luni. 2 gigs of data, that sounds great. You should definitely enter. Okay, so let's carry on, and we're going to be looking at functions now, which of course is always going to be in every paper one that you do. So I've got the information on the first page, and then the diagram is on the next page. So let's just read through what we have here, and then we'll look at the associated diagram. Okay, so we're told that the diagram shows that we have the graphs of f of x is equal to ax squared plus bx plus c, and g of x is equal to b to the power of x plus q. So what we can see is that we have a quadratic function over here, and we have an exponential function over here with a lot of unknowns. So we don't know any of those values of a, b, c, or BQ. Okay, then we're told that A and B are the x-intercepts, E is the y-intercept, and C, with the coordinates minus 3 over 4y, is the turning point of F. So let's just have a look at that now. Okay, so here we can see we have F is that parabola, which is obviously associated with the quadratic function. It's a happy parabola, and we can see it comes down, negative gradient, turning point over here, point C, and then turning around, going up. And as was explained, there's A and B over there. Those are the x-intercepts of F. Okay, let's go back. Okay, we also told that J is the x-intercept and D is the y-intercept of g. Okay, so let's go and look at that now. So here we have g. G is this exponential function, and we can see there j is the x-intercept, and d over here is the y-intercept. Oh, and let's not forget that d over there, that's the y-intercept of the parabola. Okay, sorry, I went forward instead of back. Okay, and y equals -8 is the equation of the asymptote of g. And finally, we're told that h, which has the coordinates 1, -5, is one of the points of intersection of f and f and g. So there's h over there, which we can see is one point of intersection. There's another point of intersection over there. And here is the asymptote. This is the horizontal asymptote of that exponential function, and it has the equation y equals -8. Okay, let's look at the questions now. The first question is, write down the coordinates of d. So when you're asked to write down coordinates, it's probably going to be out of very few marks, possibly 1 or 2 marks only, and you don't necessarily need to show your working. You can just literally write down the coordinates. So let's have a look, go back and look at that. So d is the y-intercept of the exponential graph. So this exponential graph has been translated downwards by 8 units. So it used to have a horizontal asymptote that was the x-axis, but now the horizontal asymptote has moved all the way down to y equals -8. So if we think about what this exponential function would have looked like before it was translated down, it would have looked like that, and it would have gone through 0, 1 on, would have gone through 1 on the y-axis, which has the coordinates 0, 1. So because the whole function has been moved, translated down by 8 units, this y-intercept has also been moved down by 8 units. So instead of being 0, 1, we know that 1 minus 8 gives us -7. So therefore, the y-intercept has moved down from 1 to -7. So therefore, the coordinates of point D are 0, -7. Okay, there it is again. We're going to use the diagram for the next question. Okay, the next question says, write down the value of Q. Okay, so we were told that g of x is equal to b to the power of x plus q. So there's q over there, and it is equal or tells us about the horizontal asymptote of this exponential equation. So y equals q is always the equation of the horizontal asymptote. So we can see that the horizontal asymptote has the equation y equals -8. Therefore, q must also be equal to -8. Okay, so if you know the horizontal asymptote, you can definitely get that value of q. Okay, so let's move on to question 2. Question 2 says, show that a is equal to 2, b is equal to 3, and c is equal to -10. All right, so this is asking us to find the equation of the parabola effectively. So we're going to have to turn our attention to that quadratic curve. So we know that f of x is equal to ax squared plus bx plus c, and we're being asked to calculate the value of a, b, and c. Okay, so just looking at this parabola, we don't have very much information. We don't know a lot about it. We don't know the x-intercepts. We don't even know the y-intercept over there, which is e. What we do know is that this point h lies on the parabola as well as the exponential curve. And then we know the x-intercept, the x-coordinate of the turning point down over there. So we don't have very much to go on. But if you look carefully, the equation of the exponential curve was y, or g of x, is equal to b to the power of x minus 8. So we know that q is equal to -8 from the last question. And because those are the same variable, they're actually the same value. So if we can find the value of b over there, the base of the exponential equation, then we can use that same value of b over here. Okay, so we have a point that lies on the exponential curve, so we sorted to be able to find that value of b. So this point h from here, we know that when x is equal to 1, y is equal to -5. So I can sub both of those values into this equation here. So if y is equal to b to the power of x minus 8, I'm going to sub the minus 5 into there, and I'm going to sub the 1 into there. So therefore, minus 5 is equal to b to the power of 1 minus 8. I'm going to take that over to there. So I've got minus 5 plus 8 gives me 3 is equal to b. Okay, so I found the value of b, and I can now move my attention to both the a and the c. Okay, so I'm just going to delete that and write up here that b was equal to 3. So I can now change my equation slightly. I've got f of x is equal to ax squared plus 3x plus c. So I'm getting there. All right, I can now use the next part, or the next thing that I know is that x coordinate of the turning point, and that is always the x coordinate is equal to minus b over 2a, and I know that b is equal to 3 now, so I can sub that into there, and of course I can sub the minus 3/4 into there, and I can use that to solve for a. So minus 3 over 4 is equal to minus 3 over 2a. I'm going to cross multiply over there, so I get minus 6a is equal to minus 12, multiplying across, which I can do when I've got one fraction on each side of the equal sign. So therefore, a must be equal to 2. Okay, so I've got my a. All right, so I just need one last value, and that is c. And for that, I'm going to substitute in the point that I know, which is the 1 and the minus 5. So again, I'm going to just erase some of that. Okay. So f of x, or let's say y rather, because we're going to sub a value of y, and y is equal to 2x squared plus 3x plus c. And finally, I'm going to sub that into there. So minus 5 is equal to, and I'm going to sub that 1 into all the values of x. So it's 2 times 1 squared plus 3 times 1 plus c. So therefore, minus 5 is equal to, that's 2 plus 3 plus c. This gives me 5, which I'm going to take to the other side. So I'm going to have minus 5 is equal to c. Therefore, c is equal to negative 10. Okay, so I've now showed that a is equal to 2, b is equal to 3, and c is equal to negative 10. Okay, let's see what the next question is. All right, we're asked to write down the range of g. Okay, so remember the range is all the y values for which that function exists. So we can see that the exponential function exists all the way down to the asymptote, and then going all the way up to plus infinity. So we can see those are the values of y for which this function exists, that exponential function. So we can write an inequality. You can use an inequality, or you could use interval notation. Either would be absolutely fine. So we can say that y is all values that are greater than negative 8. We don't include negative 8, of course, because the function never actually is equal to negative 8. It approaches that asymptote, but is never actually equal to it. Okay, the line with the equation y plus 9x is equal to negative 28 is the tangent of f at point t. Determine the coordinates of point t. Okay, so let's just think about what's going on here. We have this parabola, and there's a point t, and a tangent is touching this function f at that point t. If we look at what this line, let's get that in standard form. So we can say that it is y equals minus 9x minus 28. So we can see that the gradient of this tangent is equal to negative 9. It's very steep, negative and very steep. So it might be doing something like that, coming all the way down, obviously touching like that. So we need to figure out the coordinates of point t over there. So if we can find the gradient of f at that point by using some calculus, by doing some differentiation, we know that the derivative of f must be equal to the gradient of the tangent at that same point. So it must be equal to negative 9. Okay, so we now know that f of x, because we know a, b, and c. And the great thing about the way that they asked the last question is that even if you couldn't quite show that a was 2, b was 3, and c was negative 10, you're allowed to use those values now to get the correct function. So we have 2x squared plus 3x minus 10. We're now going to find the derivative of that, and this is a nice, easy function to find the derivative of. It's 4x plus 3. And we can now make that equal to negative 9, because the gradient of f will also be equal to negative 9 at point t. And we can solve for x. So we have 4x is equal to negative 12, which means that x is equal to negative 3. Okay, so we have the x-coordinate of this point is minus 3. All we need is the y-coordinate. Don't forget the y-coordinate. You asked for both the x and the y-coordinate. Okay, so to get the y-coordinate, we're going to substitute that negative 3. And we can either substitute it into the equation of the straight line or the equation of the parabola, because obviously that's where they both, at point t, they both touch, they intersect. So we could substitute it into either the straight line or the parabola. I'm going to choose the straight line because it's a bit of an easier equation to substitute into. So I've got y plus 9 times negative 3. So I've subbed my 3 into that x over there is equal to negative 28. So this is y minus 27 is equal to minus 28. So y is equal to minus 28 plus 27. And that gives me negative 1. And that's the y-coordinate of that point. Okay, let's see if we can do one last question. Okay, we're given that h of x is equal to g of x plus 8, and then we're asked to write down the inverse in the form y equals blah, blah, blah. Okay, so let's first find what h of x is equal to. So we know that g of x, if you remember, was equal to 3 to the power of x minus 8. That was the value of b, that was the value of q. So therefore, h of x must be equal to 3 to the power of x minus 8 plus 8. So obviously those disappear, so we just have that y is equal to 3 to the power of x. Okay, and when you find the inverse, if you remember, for inverses, we always swap the x and the y around. Okay, so we literally just take the x, move it into the place of the y, and take the y and put it in the place of the x. So for the inverse, we're going to have x is equal to 3 to the power of y. And here, this is where our knowledge of logs is going to come in. So we need to make y the subject of the formula. So y is going to be log base 3 of x. Okay, so that's all we're going to do on functions. I hope that was useful. And that's the end of this little segment. So I'll hand back over to Luni.
Thank you so much, Nicola. Guys, we are going to take a break. Before we do, don't forget to send us your questions and comments on WhatsApp as well as our social media pages. And don't forget to enter that competition to stand yourself a chance to win data. But then let's take a quick break and we'll see you straight after this. Welcome back from the break, Matrix. I hope you're still enjoying the show. I'm not going to waste any more of your time. I'm going to take it straight back to Nicola.
Thank you so much, Luni. All right, well, let's get on with the last segment of the show, and we're going to try and squeeze a bit of calculus in, and we're going to hopefully do a little bit of probability, a bit of counting methods at the end. Okay, so let's look at this question, which is question 3. The diagram, which we don't have in front of us, but it's definitely there. It's on the next page. I'm just going to read it though. The diagram shows triangle ABC drawn such that its vertices lie on rectangle PBQS. Okay, so let's have a look at that. All right, so there's our triangle ABC, and of course there's our rectangle PBQS. Oh, and we have it again. There we go. All right, now we're also told that PA is equal to SC is equal to T centimeters, so that's our variable. I think there's supposed to be an equals there, sorry about that. PB is equal to 12 centimeters and BQ is equal to 7 centimeters. All right, so that's all the information that we have. And we then asked to calculate the smallest possible area of triangle ABC. Okay, so as soon as you're asked for the smallest of something or the largest of something, this is very clearly going to be a min-max type of problem. Okay, so this is your min-max problem solving question. And for that, of course, you're going to be using your calculus. All right, so first of all, we need to get an expression for the area of that triangle. And we saw that we had one variable there, t. So the area is going to be in terms of t. And then we're going to hopefully find the smallest area. I'm going to solve for that value of t. Okay, so what we're going to do here is we're going to now find an expression for the area of that triangle. So looking carefully at this triangle, we know that the area of a triangle is equal to half times base times perpendicular height. But we don't really have enough information to be able to use that formula directly because we don't have a height that is perpendicular to one of those bases. And we can't use any trig because we don't have any angles. So the only way we can really find the area of that triangle is to find the area of the rectangle. Okay, so the area of the triangle is going to be the area of the rectangle minus the three smaller areas of the three smaller triangles that we can see. So this one over here, this one over here, and that one over there. And luckily, those are all right-angled triangles. So we're going to be able to use our triangle formula quite easily to find the area of all of those three triangles. So it's going to be the area of the rectangle minus the three areas of the smaller triangles. Okay, so I'm going to break this up into parts and then bring it all together at the end. So let's first look at the area of the rectangle. That's obviously just length times width or length times breadth. So that is going to be 12 times 7, which is 84 centimeters squared. I'm now going to find the area of each small triangle. So let's just do that. I think what I'll do is find the areas on the shapes themselves. Let's do this in red. Okay, so as I said, this is a right-angled triangle. So for each triangle, I need to know the base and the perpendicular height. So the perpendicular height is 7. This over here, which is the base, that is equal to the length of the rectangle, which is the 12, this whole length, minus the t over there. So that is 12 minus t, and that is 7. So the area of this triangle is a half times 7 times 12 minus t. Sorry, that 7 came out a little bit funny. Don't know what happened there. Okay, so it's a half times 7 times 12 minus t. All right, this little triangle over here, also right-angled triangle. So this base is t, and the perpendicular height, which is that length over there, is the whole breadth of the rectangle minus the t. So that is 7 minus t. Okay, so the area, I'm going to do it down here, the area of that triangle is equal to a half times t times 7 minus t. And finally, this little triangle over here, also right-angled triangle, this is the easiest one because we don't have to do any manipulation. We can just say that that is a base of the triangle, and this would then be the perpendicular height. So therefore, the area is a half times 12 times t. Okay, I'm now going to put all of those together into my formula. Okay, so let's find the area of the three triangles. So that is equal to, okay, so the half times 12 times t is just 6t. And then I've got plus 7 over 2. That's this over here. That half times 7 is 7 over 2 into 12 minus t. And plus the half t into 7 minus t, which is this triangle over here. So we now have the sum of the areas of the three smaller triangles, the red triangles. Let's simplify that at this stage to make our working a little bit easier going forward. So this is now 6t. We have 7 over 2 times 12 gives us 42. And then we have minus 7 over 2t. This over here becomes a half. This is a 7, so sorry, that's 7 over 2t. And then this over here becomes minus a half t squared. All right, that gives us minus a half t squared. These two t terms actually cancel each other out. So I have minus 7 over 2t's plus 7 over 2t's. Obviously gives me 0t, so those disappear. And I'm left with my plus 6t and my plus 42. Okay, I'm going to go on to the next page, do the last bit of the sum. So we need to now subtract the sum of all those areas from the area of the rectangle. So the area of triangle ABC, as I said, is the area of the rectangle, which was 84 centimeters squared, minus the sum of all the areas of those little triangles, which was minus a half t squared plus 6t plus 42. Okay, let's finish this off. So we have 84 minus 42 gives us 42, and then we have plus a half t squared, and we have minus 6t. All right, so this is just the expression of the area of that triangle ABC in terms of t. So if I critically look at what that represents, it represents a happy parabola. We can see because the a would be equal to a half. So it would be a parabola with a minimum turning point. So the minimum value of that expression is going to occur at that turning point when the gradient of that parabola is equal to 0. And that's why we can see we're trying to calculate the smallest possible area where that quadratic expression reaches its minimum value. And as I said, that happens when the gradient is equal to 0. And we all know that the gradient is the derivative. So what we need to do now is we need to find the derivative of the area with respect to t, and then we need to make that equal to 0 and solve for t. Okay, so the derivative of the area with respect to t is equal to, okay, that's a constant, so our derivative is 0. So we have 2 times a half gives us 1, and then we have our t, so it's 1t, t minus 6. And that is going to be equal to 0. So we actually have a nice, easy sum to solve here. So therefore, t is equal to 6. Okay, so now we've solved for the value of t that gives us the smallest area. We now have to go ahead and actually calculate that area. And all that involves is substituting that value of t into the formula for my area, which is that. So the area, the smallest area, is therefore going to be 42 plus a half times 6 squared minus 6 times 6. Okay, let's come over here. So that is equal to 42 plus. All right, my 6 squared gives me 36, and a half of that is 18, and I've got minus 36. All right, so you can obviously do this on your calculator. I'm going to try and do it in my head. So we have 42 plus 18 gives 60, and 60 minus 36 gives 24 centimeters squared. And that is the smallest possible area of the triangle. All right, so let's move on to the last part, which is we're going to do a little bit of probability. All right, so we have Lwazi and Kwenga are the head boy and head girl of their schools respectively. In addition, there are 3 boys and 2 girls who are prefects. They're all going to sit for 2 photos, and they're sitting in a row. I think this row means that they're sitting in a row, not that the photos are happening in a row, but it probably means that as well. But effectively, there's going to be, so a head boy, a head girl, and then 5 other students or prefects who are all sitting in one row. All right, so the first question. In the first photo, the order of how they sit is not important. In how many ways can they sit for this photo? Okay, so we have 7 seats in a row. We have these 5 plus the head boy and the head girl. That's 1, 2, 3, 4, 5, 6, 7. So let's think about in how many ways these seats can be filled. So if the order is not important and it doesn't matter at all who sits where, this first seat, there are 7 different ways that that seat can be filled because there are 7 different prefects. So any of them could fill that one seat. Once that seat has been filled, one of the students is sitting down. So if we move to the next seat, there are only 6 ways that that seat can be filled because this seat is already taken. Okay, and so we're going to go on that each seat will have fewer or less number of ways to be filled. So once they've already got a student on them, we go lower and lower and lower and lower until we get to the last seat, and there's only one person left, so there's only one way in which that seat can be filled. So we're going to multiply all of those together, and hopefully you know that that gives you 7 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 7 factorial. All right, so all we need to do now is put that on our calculator. So we've got 7 factorial, and that is equal to 5,040. So that's our final answer, is 5,040 ways. Okay, so that's the end of our revision for Maths Paper 1. I hope it was helpful and that you learnt a bit. And good luck for these last few days of studying. I wish you all the best and all the luck in your exams. Goodbye. Back to you, Luni.
Thank you, Nicola. Guys, it's been an amazing show. I hope you took a lot of information from today's show that's going to help you for your upcoming exam. If you have any questions and comments, please hit us up on all of our social media platforms so that we can help you. Congratulations to all of the competition winners who will be announced after the show on our Facebook page. For more revision as well as our schedule, visit www.wozamatrix.co.za. But then from me, Luni, Nicola and Nicoline, thank you and goodbye.
Woza Matrix 2021 Catch-Up is brought to you by the Department of Basic Education, NECT, ETDP-SETA, SABC, MultiChoice, and DBE TV on OpenView Channel 122 in partnership with